Good morning and welcome to the CABE webinar for Wednesday the 18th of November. Today we're looking at sustainable user innovation in residential buildings with Liz Varga. My name is Jordan. If you've joined us before, you will know already, but I am the Regional and Student Services Coordinator here at CABE and I will be the moderator for today's session. If you would like to send in any questions or comments, etc., we do encourage you to do so. So you can send in anything via the questions box on the control panel on your screen. You can email webinars@cbld.com or you can tweet us using the hashtag CABECPD. So this morning, your presenter is Liz Varga. Liz is the Professor of Complex Systems at the University College of London and Section Head for Infrastructure and Cities in the Civil, Environmental and Geomatics Engineering Department. Liz leads the Infrastructure Systems Institute, which is spearheading innovative research such as distributed self-organisation and digital twins into resilience, sustainability and effectiveness using complexity and appropriate methods for evolution and assessment, particularly agent-based modelling. Liz has published more than 60 journal articles and is a fellow of both the Chartered Association of Building Engineers and Higher Education Academy. With that, if you give me a couple of seconds, I'm just going to hand over to Liz now and she will take you through her presentation.
So good morning, everyone. I just wanted to show what I look like now so that you know who the face is behind the words. I'm going to turn my webcam off in a moment, but I just want you to say thank you so much for coming to listen to this webinar, and I hope that you've engaged with the survey that we had beforehand. So can you see my screen?
Yeah, we've got your screen up now.
And you got the slides?
Yeah.
Okay, excellent. Thank you very much. So this talk is on sustainable user innovation in residential buildings. And as Jordan said, I work at UCL and run the Infrastructure Systems Institute. So before I go into the detail of the project, I just want to say thank you to the funders who were the European Commission. The project was funded under the 7th Framework Programme and was led by Frank Martin Bells at the Technology University Munich. The coordinator on the project was the European Academy of Business and Society, who are now called ABIS. So they've dropped the European and are now a global organisation. So I strongly recommend you look up ABIS. They're a really interesting outfit. So we've produced a variety of outputs for the project. We have journal articles, but we also have project reports. And you can, I've shared the link here on the slides to the final report on the project, which is several thousands of words long, and you can see is a diverse collection from all the academics on this European project. Now, we also created a model, and I've shared the link here. Anyone can use the model. I'm not proposing to go through the model in this seminar because I'm not trying to sell the model to you or demonstrate the technical part of it, but I'm more than happy to have inquiries afterwards. Okay, so let's have a look at what the problem is that we're trying to solve. So we're trying to assess the sustainability of user innovations at the household scale. So this is, if you like, the building envelope scale. So what goes on inside a household, including the building itself. Now, the things we need to do is to agree, first of all, how we measure sustainability. And I've got some slides on that to come up. We also need to find a way to describe households that will allow us to use that sustainability measure. We also need to know what does it mean if you're doing a user innovation as opposed to an ordinary innovation. And then we need to quantify how much sustainability improvement is as a result of this intervention. So as I said, the context was Europe. So we need to be able to measure this for any scale within Europe, perhaps national scale, maybe regional, city scale, but we've got to be scale free in that regard. And the method that we're using is a computational model, and you saw the link on the previous slide. So I sent these poll questions to Jordan, and I think we've had some responses that we're going to share the results of at the end of my presentation. But I just want to go through the poll questions because I think it's quite important that we're all on the same page about what I'm trying to sort of convey on this presentation. So the first question was about how sustainable is any building intervention? So would the intervention depend on the life cycle cost? Could we use that as a measure of its the sustainability of the intervention? Could we say it's sustainable only if it uses renewable sources? Or would it depend on the legislation or indeed regulation that tells you whether something is sustainable or not? So that was a like respond with one of these options. Similarly for this one, how can users actually innovate sustainably? So the user community is quite broad. It's obviously the household constituents, but actually there's a broader ecosystem, if you like, of users. So could we say they can innovate sustainably through changing their behaviours, through allowing technology to provide the most sustainable choice? So this is about automating decision making so the users don't have to be involved in their decisions. Or would we need them to be proactive, so deliberately buying sustainable products in order to be innovative? The third question was about what assumptions should we make to let us assess the sustainability of a given user innovation? And the questions are, can we even assess how the user innovation will affect different types of buildings in whatever target European location we choose? So is it possible for us to assess it? Because we're looking into the future, can we even know how sustainable an innovation can be? Can we be sure that we won't double count or maybe overlook some of the aspects of sustainability? How can we be certain we've done that? And how can we be certain we've taken account of all the subsidies or policies, interventions, taxation that would incentivise policy making, so that would incentivise policies towards sustainability? And then the last questions, the last of the 4 questions was about how quickly can households become sustainable? Excuse me. So would we say that by 2050 they have to be sustainable because various legislation in different countries are demanding sustainability by 2050? Could we say that actually some buildings are already sustainable, and buildings certainly using Passive House standard we could argue are sustainable by particular measures that we can use? Or could we say actually they can't fully become sustainable until they use local renewable resources or some other means? So this was sort of the setting up of what we're trying to, the scope of what we're trying to assess with this webinar. So let's look at sustainability. So how would we define sustainability? Now, you've probably seen this drawing of sustainability in various forms before. So sustainability is at the centre, at the intersection of addressing environmental concerns, addressing economic concerns, and addressing social concerns. But in fact, most building, most interventions into building must tick the economic box. You would never invest in something that was economically infeasible. So in many respects, the economy takes a bigger circle, if you like, than all the other aspects. Now, we know we have to do environmental impact assessments, and there are minimum regulatory and legislative demands. So we know we have to do that environmental aspect of it. So we have to almost tick the boxes, and sometimes actually some of these assessments are tick box exercises. And indeed, the society part, the social impact assessment, seems to have been tagged on almost to environmental impact assessments. So although, as I say, sustainability appears to be an equal weighting of all these things, in fact, they're not equally weighted at all. And this is one of the challenges to how deep sustainability assessment needs to be. And when we think about measures for sustainability, we might think of the Brundtland report and say, well, actually, we want to assess the sustainability of a building based on, are we using resources now that would compromise future generations? But actually, that's really difficult to measure, because how do we know that the resources, that it's okay to consume resources now because future generations won't need them? We can't predict whether future generations will need them or not. Or maybe we take an Arnie Nass perspective, who framed sustainability very much in ecocentric terms. So what he wanted to do was make the environment the bigger circle. So don't worry about the economy so much or society so much. Let's focus on the environment. So to be ecocentric, not human-centric, which is what we would argue the Brundtland work is. Now, depending on which way you think about sustainability, it has implications for our social institutions and the governance of, in fact, all interventions and all innovations we make. So if you take the Brundtland approach, which is definitely the way that building engineering works, it's more of a reform approach. Yes, we can use the structures of our existing institutions, we can modernize them towards having ecological recognition, but we reform, we slowly change, we don't transform. If you take the Arnie Nass or deep ecology, environmental ethics type of perspectives, actually you need some fundamental reorganization, which is about environmental ethics. So that becomes the primary goal. So we need to know what it is that where our focus needs to be. So it's one of the things that we have to answer when we want to measure sustainability. And so what we came to as a result of the project was that we could actually measure it through two different measures. The first would be carbon dioxide emissions, which we largely know how to measure, but of course varies depending on the technologies that are used. So we just have to be careful to say which metric we're using from which time. And the second metric we came to was that you could measure it through consumption of non-renewable resources. So actually, if you can be sustainable, so long as if you carried on using renewable resources all the time, you would get the tick box. You wouldn't have to, there wouldn't be no question about were you sustainable or not. But if you were consuming non-renewable resources, then that was not contributing to sustainability. Now, there was a project that was run in Europe called Spread. Again, these can be found on the internet. These are publicly available. And what they had was a coherent way of looking at integrated households and actually allowing us to consider futures that were sustainable. And this was one of their main outcomes. So what they've described are four what they called normative. Now, normative just means a desirable future state. So this is something that we could aim towards. And these were sustainable lifestyles. Now, what was interesting was that they recognised this importance of changing the governance regime for sustainability. So you could continue very much as you were now. And in fact, this is the singular super champions. So if we didn't change the institutions, but actually recognise that the people that knew more about technology, knew how to direct towards achieving the best outcomes for a meritocracy. So for people that could do, they were the ones that were primary in the system. You could still become sustainable, but you were in this singular super champions, if you like, quadrant. These other three were different governing institutions. I haven't got time to talk about the detail of these, but again, I can point you to the resources. You can find it with the link here anyway. Now, what was fundamental to all of these possible futures for sustainability was that they all demanded an 8,000 kilogram per annum per person maximum footprint. Right, so this was, if we consume more than 8,000 kilograms per person per annum, we did not have a sustainable lifestyle. So this became our metric, our goal, if you like, for can we make a sustainable household? Well, if it was consuming more than 8,000 kilograms per person per annum, it was not sustainable. To give you an idea of the scale of the challenge, 10,000 kilometers of travel in a car consumes 15,000 kilograms per person per annum. Public transport is far less, so it means that we'd actually encourage people not to use personal transport. Certainly 550 kilograms of food per annum was what you could do if you reduced your share of meat, fish and other seafoods. So again, food has a contributory factor, but I'm trying not to focus on all of the domains that we're interested in, just targeting the buildings. So 37 square meters of personal heated living space costs us 10,000 kilograms per person per year, based on current ways of measuring. Now, already that's more than the 8,000 we're allowed. So the challenge is massive. So when we did this project, when we were working on it about 5 years ago, the average UK consumption was 40,000 kilograms per person per annum. So we're already at a scale 5 times too much to be sustainable. So it's a massive challenge on how to get here. So in order to get this quantifiable footprint, we use these measures, but we had to have some caveats about the resources. Obviously, we pick up data about the resources used at a particular date. We don't get continuous updates on data, so your data is time-stamped, if you like. We can't get data for absolutely everything, so there are some gaps. And even with CO2 emission, we do have some precision uncertainties. We can't be absolutely certain that we're measuring accurately. So already you can see that we can't be certain we can get exactly to this 8,000 kilograms per person per annum. So the 4 domains in the household envelope are the living domain, which is actually the building construction, the materials used for it, the insulation, the ventilation, the windows, the loft space, the floor, anything to do with the fabric of the building. Obviously, inside households, people consume food, and there are opportunities to reduce footprint through food innovations. Obviously, mobility is a large part of the household, including space for the car, but actually the usage of the occupants in the house for consuming kilograms on mobility. And it's a trade-off then between, do you use it for heating or do you use it for your mobility? Likewise for energy. So on the energy domain, so this is the ways that we heat and have power in the buildings. Now, just to give you some examples so that you've got an idea of how these assessments are made and how these sort of 4 interlapping areas can manifest when we look at particular innovations. So in terms of mobility, we might say, well, if you walk or cycle, that's great because you're not consuming kilograms, you're not contributing to CO2. So that's a really good sustainable innovation. We might, in terms of the building, we might need a bike shed. So there's going to be some contribution to kilograms per person per annum because you might need some building to protect your bicycle. If we look at the intersection of food, the residential building and mobility, then you might need your larder. You might need a larder inside your building for travel food, and this could be some other storage means. If we don't consider the household the household fabric, you might say, well, we can use takeaways for food, but then that involves mobility. So if we think about mobility and energy, we think about maybe internal combustion engine vehicles or electric vehicles. They contribute to kilograms per person per annum, but they don't affect the household particularly unless you think about charge points or maybe a garage to house the vehicle. We might, if we want to think about food, you might look at the bio waste that you use for charging, maybe for electric vehicles. And indeed, if you want to have the intersection of all four, you might think of bio waste that can be stored. So we might store some sort of generated electricity in a battery from food, but that can be used for the electric vehicle. So you can see how you can build up a map of all the innovations you might want to target in order to reduce your kilograms per person per annum. Now, for these four domains, we need a way to describe each of the domains. And for the living domain, we've got these aspects of occupancy. So how many people in the building, how much space do they each have? What waste is there in the household? And this is not energy, so we're not worried about heat waste or food waste. This is just household waste. What is the construction of the building? So what materials have been used? What insulation is involved? What is the location of the building? And by this we mean, is it in an urban environment or a rural environment? And what type of building is this? And one of this was actually, this aspect came up later in the day, but this idea of if you like, living in a building that's not just designed for one family. So if you have like some sort of shared facilities, even if it's just a shared corridor or lift or whatever it might be. So flats would be like a type of building that were different from detached buildings, because it meant that you could actually, if you like, benefit from others around you, because they would reduce your demands for living, even through shared walls or shared insulation, say loft insulation. So the type became actually quite important. I don't propose to go through these others, but I have got information if people want this. Now this looks really hugely complicated. I don't propose to present the detail of this, but what we try to do is show you how those components of the living domain. So if you look at the blue lozenge in the middle, the household waste, the location, occupancy type, each component of the living domain is connected to other components, to the food section or to energy or to emissions, whether directly or indirectly. What we wanted to be sure of was that we demonstrated that if we made a change in one place, we knew what effect it would have on other things. So if you had less space, if you had less space to live in, it would mean you had less energy demand. If you had fewer people in the house, you would have fewer kilometers traveled. So these things are connected in multiple ways. So I think I've actually discussed this when I had my previous slide, but this is just to confirm what the components of the residential buildings are. So I don't need to go through these again. Now, so we need to collect then data about the households. And of course, we can't collect data about households for any or every location in Europe. So what we needed was a way for an input data stream to be created that was representative of the types of household that would have all the data about occupancy, types of building and so on, but would not be geographical, but actually could represent a geographical location. So if you had all the data you needed about a city or a country or a region, you could provide that data, including how many households, and the model could then use it. Now, the way to do this was to implement something that we call it statistically representative distributions or statistically accurate distributions. So you tell us how many houses there are of particular types. You tell us what the occupancy is. So there might be so many percentage occupancy of certain, so say 2 people, there's a 20% chance that 2 people live in a particular house. And the reason this is really useful is that national statistics can usually provide all the information we need because they're collected. And we found that actually we've done this for 4 countries in Europe, and they were reasonably easy to get. So, but obviously regional statistics can and are available, and local statistics can be obtained as well. And just to give you an example of the sorts of information and how they differ between different countries. So if we're just looking at the space available in households, so in the UK, the proportion of households with a floor area of under 50 square meters is only 11%. Whereas in Spain, it's something like 0.059, so about 6% of houses are like that. So if you look at the bigger differences, the proportion of households with between 70 and 89 meters squared in the UK is 28%, but in Spain it's 33%. So you can see how already the distributions vary across different countries. So the input data to the model, if you like, the starting position of the model will vary depending on the location. Another example is the energy efficiency. So we used what's called a triangular distribution, which basically you give a lower and higher bound. So what's the minimum efficiency of a building? What's the lowest efficiency we expect? If our middle point is the mode, we expect to say households to be 100%. If we expect households to be, say, 50% efficient, then some households could be 100% efficient, but maybe the lowest efficiency is 25%. So we have this idea of a representative distribution of where most households are. And these are also collected by energy agencies in different countries, so we can get this data as well. Again, if we look at Office for National Statistics, we can use census data for things like occupancy. So we can see here that actually almost a third of all our buildings have 2 people in them. So 34% have 2 occupants. What's interesting on this slide is that we have 0 buildings with no occupants. We know that's not true. We know there are empty buildings. And we also bundle people with buildings with more than 6 people. So although it's a small percentage, 2%, they might contribute to a lot of kilograms consumption because these could be large buildings with large numbers of occupants. So it could, although the distribution is useful, it might not represent the true diversity of the whole system. Now, interdependencies are really important, and we tried to manage those by looking at the connections between the components on that really messy map that I showed you earlier. Now, the sorts of, there are interdependencies not just between the domains, but between specific parts of the components. And we might sort of have assess the types of interdependency. Certainly, there's a co-location dependency. So, you know, if your electric vehicle is in a particular house with 2 people, those interdependencies matter because you're looking at the connections between those physically co-located entities. There might be cyber interconnection. So you might have data about something, but they needn't be physically co-located. So you might know the information. And also the coupling might be tight or loose. You might be like hardwired, or you might be loosely coupled so that we can actually break that coupling quite easily, which is really, well, you need to know that in order to know if an intervention would work. So we create the model based on our map that I described. We can calibrate it to make sure that it does give us this 40,000 kilograms per person per annum if we run the model. So with the answer, if you like, from the model is about 40,000. I can tell you it doesn't come exactly to 40,000. It's within a small tolerance of that, and usually tolerance is of 5%. We also tried to run the model using the spread scenarios. Now, this was to show that the model could actually give you an answer of 8,000 kilograms per person per annum if you implemented changes to the system. So if you implemented changes to the housing, the occupancy, or to the ways that the materials that we use, that you could actually result in this 8,000 kilograms. So we were happy that the model was giving you, if you like, the right calibrated results, because then we could try out user innovations. But what we found actually was we could use the model to try out systemic innovations. So we could say, well, say we wanted more people in buildings. So how could we increase occupancy? If we change the occupancy, we could immediately, without any innovation at all, we could actually see what the effect would be. So if we change the distribution that I showed you before to be skewed towards larger occupancy, then we could see that actually the 40 kilograms per person could come down to, it was around 30,000. So already it's giving you a clue about the sorts of innovations you could do on a larger scale. We could also model what the construction efficiency, if we change the construction efficiency, how much better would the outcome be? And we could do these either independently or together, because the model's integrated. So you can't just do one innovation and add it to what the other innovation would be. You have to do them together to see what the integrated result would be. So it's not you can't sum independent innovations, which is why you need a model and not a spreadsheet. Okay, so back to the actual project. So the case studies that we used were developed by the guys in Holland and Sweden and Germany. So they were the ones that actually interviewed the people, the different types of innovation that we could do. Again, these are available, and I can give you more information if you ask me later. The second major work that was part of the project was to identify the roles in sustainable innovation. And actually these were really interesting, because actually it showed us that it wasn't just the user consumer, which is actually the bottom on the list. So if you like, the person in the household that could help us innovate, there was excuse me, like an ecosystem of user innovators that were necessary to keep user innovations in place. And so we had things like user producers, so people who could actually, who were users to start with, but became entrepreneurs and actually produced sustainable innovations. We had people who would legitimate these innovations. So basically people who would influence what we call social discourses. So you have the narratives about the like how the niche innovations could become mainstream. You had user intermediaries who would help build those whole socio-technical systems. So both how society could interact with the innovation, as well as how the technological system could interact. And then you had the idea of user citizens, people who would, if you like, challenge the dominant regimes and try to destabilize a bit like the Arnie Nass position, where you actually want to give primacy to the eco-centric position. So if we assume we have all these user innovators in place, what that means is actually that the user innovation will stick. And so this is really important for the quantifying the outcome, because often innovations don't stick and people go back to what they were doing before. So here we have that the policies for sustainable innovations really matter. Now, policies can help help users adopt more quickly. And what we found was that the traditional modes for sustainable development were not going to achieve sustainability, for this very reason, that people go back to their behaviours. So in order to innovate in a way that will make an impact, we have to do this socio-technical change, which means that we worry about the method, the process of innovating, as much as we worry about the what we are innovating. And it includes selling the whole innovation to and so that people buy into the values and mindsets that we need in order to keep the innovation in place. So we need to be just as mindful of how we're going to do the innovation as doing the innovation. And what we saw was actually this movement from classical, if you like, consumerism, the way that people normally do things, towards a community innovation where you had some sort of co-production, active participation from not just the consumers in the household, but this whole collective of users that were for sustainable innovation. Now, what this meant was, academically, it was the intersection of sustainability domains, of user participation domains, and these ideas of co-creation and co-production of sustainable innovations, but also the innovation domain. And we already have this idea, excuse me, of sustainability-oriented innovation, which is this SOI, which is the intersection of innovation with sustainability. But what we were trying to achieve was this SUI position, which was this sustainable user innovation, which brought in that user participation into that innovation and sustainability domain. Now, the particular innovation interventions for the living domain, so this is the top right-hand side, were brought down to 4 types. And one was to reduce space, so to give, if you like, people less space. The other was to have more efficient buildings and the construction materials, insulation, the whole building fabric, and heating, windows, ventilation, and so on. A means to reduce household waste, and a change in type, so that we reduce the amounts of detached buildings, essentially, so that they're more co-living type or shared living. Now, one of the important factors was that in looking at the whole system together, we needed to look at the household heat loss. So this was the integration, if you like, of the household with the energy domain, because they influence each other directly. So the hot water, the lighting, the appliances that are used, the cooking means, the human body heat, all these are very, very interrelated and affect the total that we come out with, affect the kilograms per person per annum. And it's in particularly in respect of heat loss. So we had some really quite detailed algorithms, which I didn't want to share with you on this particular slide, but again, I will very happy to share later, that actually showed how we dealt with heat loss and indeed avoiding heat loss. Now we can run the model then, which assumes that everyone adopts the innovation. Now, of course, the challenge is that in reality, not everyone adopts an innovation. There are people who have never used the innovation, so the people who feel excluded from it, or the people who resist an innovation and will never use it. If you like, this is the inertia in the system. And there are also people who have stopped using an innovation, basically people who've been expelled from using it for whatever reason, or people who have tried but didn't like it and rejected the innovation. So if you like, there's never 100% of people can adopt a particular innovation. So we need to find a measure of how many people might realistically adopt. And so we use this, if you like, innovation diffusion curve, where you have, there is a rate of inertia, you have some inactive households, but eventually more and more people adopt. And there is a period of adoption. So the maximum adoption would happen within so much time. We have to, if you like, do the best we can to assess how quickly that would happen. And that's, again, very related to the subsidies and incentives for adoption. So just a warning to say, of course, the model is not the same as the real thing. I mean, for all the reasons I've described already. So what we do is our best to represent the system how it is, based on some a priori, some if you like, description of how we understand the system is. And what we try to do is to give some insight into the effects of the change that could happen, but with it comes this list of assumptions and caveats, because we can't get all the data, we can't know how quickly things will diffuse. So we do our best to, through modelling, through having, if you like, an object model, which is a representation of the real thing, the object original, and gives you insights that could tell you how to change the object original, the real thing, to make a better outcome for sustainability. So some of the caveats I've mentioned already, but the scaling one is particularly important. So we model in the UK 28 million households roughly. We have 10,000 agents in our model. So each agent in our model represents 2,800 real households. It's not a one-for-one mapping. If we tried to run the model with 28 million households, the model would still be running now and not be able to give us any insights, because the processing time for these large-scale models is still not fast enough. CO2, so we know roughly what the CO2 measure is, but of course technologies continuously improve and reduce the emissions. So we have to have some assumption about how much better the CO2 emissions will be over time. So what we do is we give you a result that is the mean of the 95% sensitivity interval. So it means that we run the model hundreds and thousands of times, and we tell you that the 95% of the results are within this range, and we give you the mean of that. So these are the figures we actually give you. And so some of the figures to contemplate is that if we assume that half of the population have adopted a particular innovation, say rising or raising the occupancy level or changing the materials, then, so this is the second one, the construction material innovation. We can tell you that in the UK, we're going to reduce the kilograms per person per annum by over 4,000. Similarly in Germany, but less so in Spain. So their starting position is better with their construction materials innovation. So if you like, it's an innovation that might not be such a high priority for them, because it won't make as much improvement as it will in the UK or Germany. In terms of the CO2 emissions, however, both in UK and Germany, you're going to make a really big impact. Like 20% CO2 emissions reduction is significant. So they might well be worth investing in just for the sake of reducing CO2 emissions. I mean, I have the electric vehicle statistics there, and they're only interesting because although the kilograms per person reduces massively actually in Germany, what happens is that the CO2 emissions increases. And this is because the UK and German grids are not as clean as the Spanish ones. So you can have this, you can see already there's a trade-off between investing in innovation. You know, you actually want it to tick all the boxes of reducing CO2 and reducing kilograms per person per annum. And if it doesn't reduce, for example, in CO2, you can see that there's an action plan then to get the grid to be improved so it does become cleaner. Okay, oops. Can you still hear me?
Yeah, I can still hear you.
Okay, thanks, Jordan. Right, so I'm last bit now, so I know I'm coming up to quarter two, or I'm just at there. And just in terms of the rate of adoption, as I said before, we have to have some baseline for the rate of adoption. But actually, if we adopt slowly, it has an impact on the non-renewable resources that we're using before we actually have the full adoption. So this idea of we're creating a cumulative problem, because we're adding to the emissions in the environment which aren't going away, and we're also reducing the whole stock, if you like, the global stock of non-renewable materials. So the rate of adoption matters. And of course, the population continues to change, and we do try to account for that. Because we know that there's new housing stock, and we know that there's a reduction in old housing stock. But of course, the majority of housing stock is not new. And so we see already that retrofit innovations have the greatest impact. But inertia is a real challenge, because we can't mandate some of these innovations. And also we have the people who aren't who don't adopt as well. Oops. I just want to mention that we have assessed the validity of our model, and these are the dimensions that we used. So how useful was it to stakeholders? How credible was it? And so the credibility is based on the sources of evidence. So everything is made available to someone doing a scrutiny of the model. How transparent it is? Well, our model is available on GitHub, it's called. It's an open source platform. You can use the model online. It's transparent. Is it interpretable? We've tried to keep it as simple as possible, a household with 4 domains, but obviously some of these interconnections are really quite complicated and in fact complex in many respects because they lead to emergent outcomes. Can we reproduce our results? Well, yes, we can. Because we've done it, we can demonstrate we can. What is the external validity? So could we run the model retrospectively and show what the results are? And we've assessed that. And internal validity is about logic. And we've had that, again, we had a scrutiny panel as part of this project to assess that. So we're fairly satisfied it is valid, but there's always room for improvement. Of course, there's a great deal of uncertainty. We don't know what will happen in the future. We're more certain about the near future, but as you go further forward, absolutely, it becomes more and more unpredictable. We also know that systems evolve. Although we can imagine coherent ways how we might integrate buildings and energy, and of course the spread sustainable living scenarios are really good, coherent descriptions. Will they actually come into life? Will they come into being? We just can't be certain that people will be able to live in those ways, even though we can describe them. And of course, priorities are always changing because these are all about geotechnical regimes. We're trying to balance the economy, the environment, society. So there's always going to be more emphasis on one part. Now, what I wanted to do is to look at the poll questions, but it might be better to stop here and let Jordan share the results on the spreadsheet. And then if we have time, I can come back to what the actual answers were. And of course, I can share my spreadsheet anyway. Sorry, I can share my slides anyway. I can show you what the answers should have been if you like. But maybe Jordan, I'll go over to you.
Yeah, of course, not a problem. Just give me 2 seconds. Okay, hopefully you can see that now.
Yep. So we have more people answered the second. It's only sustainable if it uses renewable sources. Actually, that is the right answer. So well done to those guys. But actually, I think the other 2 answers are also correct because depending on who's deciding your measure, actually those other 2 can be legitimate answers. But actually, for if you like, the honest broker sustainability, I would say it is the second answer is correct. And how can we innovate sustainably? It's definitely changing behaviours, allowing technology. I see only one person thought technology would be the answer. Proactive action also. What I would say is all these possibilities are correct. None of these are wrong. You probably want a combination of them. Behaviours is probably a key one. And I have got a paper actually on behaviours and how difficult it is for people to keep their behaviours up. The third question, what assumption must we make that lets us assess the sustainability of a given user innovation? So we've got an equal top here. We have to be able to assess in any target, yes. We don't miss anything, we don't double count, or we don't miss anything, absolutely. And we take account of the subsidies. Now, I think this is also correct that those first 2 are equally important, but actually as I said in the slides, the subsidies matter because they help the speed at which we might adopt, and then over the long term, we don't have that cumulative effect. So I think they're probably all true, and probably the last one ought to have more score. And then the last one, how quickly can households become sustainable? I'm really pleased that most people have picked the last answer, because that is absolutely the right answer for true sustainability. But actually, the other two are legitimate ways, and we do use those as measures in our current institutions. So thank you so much, everyone, for participating in the poll. I think, Jordan, it's over to you for some Q&A.
Yeah, of course. Bear with me 2 seconds and I can see if we have any questions come in. Okay, so at the moment we have a couple of questions. So what I'll do, Liz, I'll just kind of read them out, and if you just answer them the best you can.
Thank you.
Okay, so the first one is a thank you for a thought-provoking presentation. And that you said that overall we need to reduce current impacts per person 5-fold, but this is based on current energy and material sources. So do you have any insight as to how much of that gap can be closed by shifting to cleaner forms of energy and material supply alone?
The vast majority of it. So essentially, the biggest impacts come from our energy use and our buildings, if you like, our buildings' thermal capacity. So if we can avoid heat loss through the construction materials, through systems that can capture waste heat or avoid heat loss, that they will be our biggest impacts. And of course, if we can have a grid that is moving towards renewables, and of course our grid is moving towards renewables, so we have already a growth in things like offshore wind farms and solar farms and so on, that are also already contributing towards a cleaner grid, that they will be the two biggest impacts on the kilograms per person per annum. So we've got to do them in parallel, and they'll have, it won't be just a single impact. We can almost like know that we will do more well if both of them are done, because we can't do one without the other. Because although we can improve our grid, if we're still using the wrong materials or the wrong technologies or the wrong behaviours, it won't be enough.
Okay, hopefully that has provided him with an answer. So let me have a look at what else we've had come in. Is there any recent research exploring the ability for humans to adjust to lower thermal comfort levels?
That's a really good question. So that I'm not aware of any research, actually. It sounds like a research gap. People actually, I can tell a little story, because you can see from this that rebound effects can occur. And the story is that the government, I think it was DEC, obviously before we had BEIS, so the Department for Energy and Climate Change, as it was before, they put out if you like, a guide to householders, which basically said, if you turn down your thermostat by 1 degree centigrade, you could save £100 per year on your energy bill. So, for example, if you turned down your thermostat, so say you've got it on 21 degrees Celsius, which is already quite warm. Say you turned it down to 20 degrees Celsius, you'd be saving about £2 a week. Can you imagine what the energy companies actually experienced? So maybe the clue was in my sort of framing of the story. There was a rebound effect. people thought, oh, if I turn my thermostat up by 1 degree, it's only costing me £2 a week and I can be really warm and cozy. So it had this rebound effect. We wanted people to turn down their thermostats, but actually it didn't do the trick. It had the reverse effect of what we wanted. So this is why sometimes trying to engage with users is one of the most tricky parts of innovation, because you need them to be, if you like, willing, participative, that you want them to be aware of the consequences, not just for themselves, but for others. So you want them to be altruistic. And this is a real challenge, because people tend to be, they care about themselves or their family in a sort of hierarchy. These are the most important units. And then after that, yeah, we care about our neighbours, yeah, we do care about society in general, and so on. But there's this, this feeling of we've got to look after ourselves first. And if they can afford to look after themselves, then they will do. So it's a really, really big challenge. I think we need more research on the social acceptability of turning down the thermostats, but there's also, I mean, I'm not a techno, I'm not sort of pro technology for itself, but there are opportunities in technology to certainly try to make the temperature more comfortable by the sort of clever technological interventions that can be made. So overall, we can reduce the amount of energy used by making sure that we never let the building get too cold, that we sort of maintain a lower temperature throughout. And that is actually cheaper than making it like flip between very hot and very cold. So again, technology has got a role to play. But no, so it's a great question. Yes, I think more research should be done in this area.
Lovely, thank you. So we actually have a lot of questions coming in quite rapidly. So I think what I might do is send them over to you, Liz, and then we can put together a flyer that I can email out to everyone.
Yeah.
Just rather than me kind of throwing all these questions at you, because there are a lot popping in.
That's
and obviously,
great. Thank you.
Obviously, we want to be able to give everyone, the correct answers that aren't necessarily rushed. So I think if we do it that way, then hopefully we can provide some very good answers to these questions. So I think with that, we'll kind of wrap up. So just a couple of things from HQ before I close the session. We have secured a further 2 e-learning courses, so please do take a look at those on our website. We are also looking at holding more of our training courses virtually. So we have successfully held certificate and building control online for the first time recently. So please keep your eyes peeled for more dates that should be appearing on the website shortly. Or if you have any questions or would like to know more, please email the training team. Also, our regional AGMs and elections have now been announced. So if you would like to get involved or have any questions regarding this, please do email myself and I'll be more than happy to help. So with that, I just want to thank Liz for joining us this morning and for providing that very informative presentation for us all. Thank you very much to everyone who has logged on and joined us, and for all of the questions that we have had. It's great to see you guys interacting with us. As mentioned, I will send them over to Liz outside of the session, and I will send out an email with a Q&A flyer as soon as possible. Our next webinar is on the 2nd of December at 11 AM, and that is on recent changes and updates to fire safety standards with John Davidson of the National Security Inspectorate. So again, if you have any feedback, comments, or any ideas for future webinars, please do email myself. But with that, thank you again. I'm going to wrap up now, and hopefully I will see you all online again very soon.
Thanks, Jordan, and thanks everyone.